So this is the chapter 4 activity page 2. We did a lot of work on the previous page. This is the cleaned up version of the two probability distributions. One was for the number of siblings, and one was for the number of pets. And this is referring to the statistics student survey where you were asked how many siblings or how many pets you have. And I may have made these numbers up. I don't think these are real numbers. I do not recall at this point. So let's take a look at the top. In any probability distribution, the probabilities must each be between 0 and 1. These probabilities cannot be like 1.5. The lowest is 0, the highest is 1, and they must add up to 1. So those are the two requirements. And I seem to be repeating that information right here. So 1 is the same as 100%. So those are the two requirements for a probability distribution. Down here, I summarized the value of the mean and standard deviation for both distributions. I showed you how to get the mean by hand. I did not show you how to get sigma by hand. It's a little more involved, and I don't really care that much about you knowing how to do that. It looks like my predictions on page 1 were wrong. The average number of siblings is a lot higher than the average number of pets, and the variation in siblings is higher, and the variation in numbers of pets is lower. Now, here's the types of questions that I like to ask after I provide you a table like this. So again, this table is called a probability distribution. I can ask you, what is the probability that someone has 3 pets? And so I come over here to the 3 pets, and so there's a 6% likelihood, or a 0.06 probability that someone has 3 pets. It's pretty low. Actually, that table kind of helps me see why there's lower variation in pets and higher variation in siblings. So if I just look at all of this, it seems like the pets are really kind of closely clustered together. The majority of the people have 0, 1, or 2 pets. But when you go to siblings, you see it's a little bit more spread out. So there's probabilities 1, 2, 3, 4, and 5 are all kind of, so there's a little bit more spread outness or variability in the number of siblings. I can just see that by their probabilities. Now I could ask, what is the probability that someone has 3 or fewer pets? So for 3 or fewer, I would add up these probabilities. I do include 3, and I include all the probabilities lower than 3. So 0.25, 0.25, 0.31, 0.06, and I get 0.87 for my total. What is the probability of 2 siblings? It's just 0.42. What is the probability of more than 4 siblings? So more than 4 does not include 4. Whoops, I meant more than 2 siblings. So more than 2 siblings does not include 2. So I would add up all of those numbers. That's a lot of numbers to add up. So you can add them up and get 0.48, or you could be clever. Check out this clever move. I add these guys up, 0.06 plus 0.33 plus 0.14, enter, and then I do 1 minus that answer, and I get 0.47. So this is 0.47. This is This is 0.53. This is 0.47 or 0.48, depending on how we work it out. It's pretty close. When we totaled it, it was 0.48. Just pointing out to you that all the probabilities have to add up to 100%. So if you didn't feel like adding all of these values, which they do add up to 0.48, you could say, what is 1 minus 0.53? And it's a little annoying that we get 0.47 that way. Let me just clarify here. These three add up to 0.53, and these add up to 0.48. And I know that if you do 0.48 plus 0.53, you get 1.01. That is because somewhere along the way we rounded and some of the decimals got a little tweaked. So it really should just be 1. I'm not going to sweat this. So if you had accidentally put 0.47 here, then that would be fine. I wouldn't get upset, because that would be 1 minus 0.53. So your method is correct, it's just rounding that makes you be off. Let's continue and look at the graphs here. This is really nice to have a visual. This is the relative frequency graph or the probability graph. And you can sort of see here that there's more variation in siblings. It's a little bit more spread out, and pets are a little bit more clustered together here.